In this lesson, we are going to talk about powers when the exponent is rational. By rational, we mean fractions. So far, what we have seen is powers with the exponents to be integers. But now, what about if the exponent is a fraction? How do you evaluate those? We define any base, a, exponent m over n, where m and n are natural numbers. By natural numbers, we mean 1, 2, 3, and so forth. And n, also a natural number, and a greater than 0. We do not define it for a to be 0 or negative number. Then a exponent m over n is equal to root of n, which is the denominator here, and m is going to be the exponent under the root here. So a exponent m. Give you example, for instance, if I say 2 exponent, let's say 1 over 2, which you already know 2 exponent 1 over 2 is square root of 2. Remember, the denominator goes here, so this is 2, and the exponent becomes the numerator, which is 1. So this is really square root of 2, which you already have seen it before. Just remember that natural numbers are numbers in the set of 1, 2, 3, and so forth. So let's do a couple of examples here. The first question is, how do you evaluate 49 exponent 1 over 2 without the calculator? I know that 49 can be written as 7 exponent 2. And then 1 over 2. You remember power to power, we are going to multiply the exponents. So this is going to be 7 exponent 2 times 1 over 2, which is exponent 2 over 2. You multiply 2 and 1 over 2, which is going to be 7 exponent 1, which is 7. So that's the first example. In this example, I have to find the root 3 of negative 64. I can write negative 64 really as negative 4 exponent 3. And then we also have exponent 1 over 3. Now, when you have power to power, you multiply the exponents. So I'm going to get negative 4 exponent 3 times 1 over 3, which is going to give me negative 4 exponent 1, which is simply negative 4. The next example is 32 exponent 4 over 5. I can write 32 as 2 exponent 5, and then exponent 4 over 5. Since I have power to power, I'm going to multiply the exponents, so I'm going to get 2 exponent 5 times 4 over 5, which is going to give me 2 exponent 4, because 5 cancels with 5, so I get 2 exponent 4, which is 16. The next example is 0.04 exponent 3 over 2. Again, as usual, I'm going to write 0.02 as 0.2 exponent 2, because 0.2 times 0.2 gives you 0.004, and the whole thing exponent 3 over 2. Again, I multiply the exponents. I get this is equal to 0.2 exponent 2 times 3 over 2, which is going to give me 0.2 exponent 3, because 2 cancels with 2, and 0.2 exponent 3 is going to give me 0.008 when you use your calculator. Now we are going to talk about a few facts here. When you have two powers which are equal, like a exponent b equal a exponent c, when the bases are equal, like here, which is a, then it means that the exponents, they have to be equal, meaning b has to be equal to c. Again, the bases, they have to be equal. If they are different bases, then this fact is not true. For instance, if I tell you that 2 exponent x is equal to 2 exponent 2, the only possibility is that since the bases are the same, the powers, they have to be the same, the exponents. So x has to be equal to 2, no other way. That's one. The other thing is that if you have two powers with different bases but the same exponent, again, this time the bases, they have to be the same. Meaning, if I know that, for instance, x exponent 2 is equal to 3 exponent 2, since the exponents are the same, this means that x has to be 3. There is no other way that x can be any other than 3. Now let's see how we can use these two facts to solve equations which are exponential equations, like x exponent 4 is equal to 16. How do you solve this one? First of all, this is not a linear equation. The reason is that the exponent of x is 4, it's not 1. So this is not linear. To solve this one, I will try to express 16 as a power with the exponent of 4. Hopefully I can do that. And fortunately, I can write 16 as 2 exponent 4. Now we use the first fact. We say that the second fact, we say that the exponents are the same, so this means the bases, they have to be the same. So x has to be equal to 2. That's the only possibility here. So the solution is x is equal to 2. The next example, we have x exponent 3 over 2 is equal to 27. How do you solve this one? Again, since the exponent here is other than 1, this is not a linear equation. So we have to somehow isolate x. To isolate x, we are going to look at this equation, and we will see that 3 over 2 is the problem. To get rid of 3 over 2, what we are going to do, we are going to raise both sides of the equation such a way that the exponent of x becomes 1. And it is obvious that if I raise x exponent 3 over 2 by 2 over 3, I'm going to make exponent of x equal to 1, because remember, when you have power to power, you are going to multiply the exponents. So 3 over 2 times 2 over 3, 3 cancels with 3, and 2 with 2, so it's going to be exponent 1. But since we raised the left one by 2 over 3, we are going to do the same thing with the right one. So on the left we get x is equal to, but now I have to simplify 27 exponent 2 over 3. We know that I can represent 27 as 3 exponent 3. So I will write 3 exponent 3 exponent 2 over 3. Again, 3 times 3 times 3 is 9 times 3 is 27. Now I have again power of power, so I'm going to multiply the exponent, so I get 3 exponent 3 times 2 over 3. Now 3 is really 3 over 1. To multiply fractions, you multiply numerators divided by the product of the denominators. This is going to give you 3 exponent 2, which is going to be 9. So the solution to this equation, exponential equation, is x is equal to 9. In the next example, I've been given the future value of $700, which is 900, after 5 years. I have to find the interest rate using the compound interest formula, which is given here. A is the future value, which is 900. P is the initial value, which is 700. I is the interest rate, which I have to find, and N is the number of years. So I'm going to substitute the values. I'm going to say 900 is 700 times 1 plus I exponent 5. First of all, this is not a linear equation because exponent of I is going to be 5, which is not 1. So I have to solve this one by isolating I. To isolate I, I'm going to divide both sides by 700. So I get 1 plus I exponent 5 is 900 over 700. But I can just cross out the two zeros, I get 9 over 7. Now, I have exponent 5 here. To get rid of 5, I'm going to raise both sides to exponent 1 over 5. So I get 1 over I exponent 5. Exponent 1 over 5 is equal to 9 over 7 exponent 1 over 5. Now, 1 plus I exponent 5 exponent 1 over 5, I'm going to multiply these two, and I'm going to get 1. So from here I get 1 plus I is equal to 9 over 7 exponent 1 over 5 is going to give me 1.0515. Now to find I, I'm going to move 1 to the right. I get I is 0.0515 because it's going to be 1.0515 minus 1, which is 0.0515, which is the same as 5.15%. So if the annual interest rate for a compound interest is 5.15%, $700 becomes $900 in 5 years, which you can see the increase is $200 because of the interest.